recording it anyway. So, oh, is first assignment a lot like the example got on Monday? Yep. Pretty much. There's only one real difference, and I wanted to go over it today because I just didn't have time last time to talk about it. Yeah, I kind of wrote that one with the intention of making it similar. Okay, so I guess the first thing to mention is, and hopefully everybody saw the announcement last night. We're not allowed to require Discord anymore. You can still use it if you have like questions. I'll answer it, or you can talk with other students. But it's not affiliated with the university anymore. So I can't hold office hours there. We can't do lectures there. But you can still use it. That's totally fine. Just not for anything official. I'm not allowed to use it. So that's about that. So there's really only one thing I wanted to go over with regards to like review, and then maybe I'll just take questions in case anybody has anything else they want to go over in C++. So the one thing I didn't go over last time, and we can open up that file really quick. I said I wanted to go over, I think it was this one, right? No. I said I wanted to go over a different way to read in things because the way I had that test thing formatted, that test file that I gave, was different than assignment 1, and I think it's a good idea to know how to read that kind of stuff as well. So let's just find it real quick. I think it was one of these, this one, right? Okay. So the way I was reading in the file last time, right, was with this. But there's another way we can read in, from the line, and it's good for files where you might have some sort of delimiter that's not a space, and that might sound a little bit fancy, but really just a delimiter means like a stop point. Like, so a semicolon in C++ is a delimiter because it tells you that you're at the end of a line when you're writing code, right? So we put a semicolon at the end of everything. So let me open that up really quick.
I'm finally getting audio.
Oh, sorry, what was that? Okay. Right. Maybe I'll do it this way. Yeah. So, exactly, oh no, whoops. How exactly do you want to do our heading with our name? Sorry, the question is off topic. Oh yeah, I mean, I don't typically take off anything for, stuff like that. I don't know where chat, oh no. That's rough. I don't know if I have an easy way to move that. I really just put your name up at the top. So I think in the syllabus I said name it like your last name and then whatever the assignment name is. But I'd say just leave a comment at the top with your name and then maybe the assignment number. The class if you really want to. I'm not going to be super picky about it. And again, I don't think I'm going to get a TA. So I guess I'm kind of stuck creating this probably. Right. I guess what I was trying to pull up is this. Hopefully I don't cover up the chat too much. So this is the cars file for the first assignment. You'll notice that's a bit different than the sample that I gave last time because everything was separated by spaces, right? Whereas this one, if I did it on spaces, I'm going to have a problem because the names here, these should all be one thing, right? This is the name of the car, and everything is separated by semicolons. So if you used like the right string, like whatever string you have, it's only going to read in Chevrolet. So using getLine is what we need to do for this. So instead of something like this in file, that what I could also do is, so you do need a string in advance. So let's just say string str. So what getLine does is you provide it the input file. So in this case, that's in file, right? The string, and then you can optionally, if you leave this blank, it will assume that it is the line feed character. But if you want, you can put a character. Remember, that's single quotes for character. So in this case, if I put semicolon, that will read in until it hits a semicolon. So if I did this now and ran it, what's going to happen is string is going to get this first line, but let's just say that's gone. It would get Chevrolet, Chevelle, Malibu, and it would get it all as one string and store it there. So if I wanted to get this whole line and do all that stuff, I would need to get the line for the name, and then, you know, do car.name equals string, and then, you know, I'm not going to do all of these because obviously it's the homework, but let's just do 2 really quick. And then I wanted to read the next one, so I'd just keep doing the same thing. And so what I would suggest doing is getting all of them in one loop, a while loop or a for loop, and then just storing it into a car struct, and then storing that in the vector, like we talked about last time. So if I wrote this here, the first get line is going to get Chevrolet, Chevelle, Malibu, and the second get line is going to get 18. Now the problem with that is that we are storing it in a string, right? And there's no overload for this that takes in an integer instead. So it's going to store it in that string regardless. What we want to do then is convert that string to an integer, because this is an integer and it would be nice to store it as an integer, right? Your car struct should have an integer. So if I have like car dot, I don't know what that is, maybe it's model, or not model, year, then there's a function, there's several of them. So in this case I would use something called s2i, which is going to take this string and it converts it to an integer. So there are a bunch of these. I've seen some people talking about it in the Discord chat. So there's s2i, which converts a string to an integer. There's s2d, which converts a string to a double, which then you can use for a float as well. There might even be one like s2b in C++, that converts it to a boolean as well, or you could just do 0 or 1. So does that seem okay? Those are just the last 2 C++ review things I wanted to go over. Use getLine if you know your strings are not going to be like strictly space separated. And then s2i, s2d you'll need in order to convert the like year and MPG and all that to integers from strings, and then the price or whatever it is to a double, whatever is a double in the program. Any questions on that? Because we have the semicolon delimiter, when it hits the end of the line, it will ignore a new line and give us... Yes, it should. Yep. I think I tested this a couple weeks ago with an assignment that Dr. Fonseca wrote, and it worked. Any other questions on that? Okay. On that note then, close this. Don't save it. So I've written a little bit of code here in advance. So from this point onward, we're going to talk a little bit about data abstraction, which is just the idea that we can kind of write code that is abstract in nature, so it might handle a bunch of different cases, and it's maybe a little more easy to read because of this. Yeah, that would be a mistake, right? Right? So we add the semicolon to stop it from running till US. Oh, or sorry, I think I answered that incorrectly. It will stop at the end line. Let me reopen that really quick. It should stop at the end line. I can check the other example I have really quick just to make sure. Yeah, so here's a program I wrote for his class. Where's the read? There we go. Read. And then the input for that was this, which was like tweets, and it was delimited with commas instead. Yeah, so you notice this one doesn't have a comma at the end either. Because in a loop, that's how we get to read it. So it should stop at an end line as well, as whatever delimiter you put. So this right here, I parsed it exclusively with get lines. So you notice I did a get line for the message, the date, time, all of that, which were all strings. Temp.id read line. Yeah, so I did it a little bit strangely, you'll notice here, but I did that mostly to set the end of file line. So I read in the first argument, which should be the source. In this case, this was like a list of tweets, where this was the source that the tweet was found on, and then the tweet itself, and then some metadata about it, like likes and retweets and all that. So here you'll notice I read in the website that it was from, and then I do it again at the end, and that's just to make sure the end of file flag gets set correctly. Because if I was to like read, let's just say on the cars thing, if I was to read in this, I'm not actually at end of file yet. I have to do one more read. So it's very important to try to do the next read, or like the first read of the next line that you're expecting to do while still in the for loop, or while loop, whatever you're doing. Store the whole temp in the vector. Was that the struct? Well, the item structs. Maybe I should have kept that open. It was a vector of item structs. And I guess vector itself is probably a struct. But let's find where I put that. There it is. Yeah, so I create a new item, which is the struct that I made for this one, and in the case of your program, it'll be a car is the struct that we're using. And then I read into that and then push that created item. Oh, temp. Yes. Yeah, and there's something important that you'll notice about both of these. So here and on the... Sorry, I'm just like opening a million files and it's hard to follow. And on the tweet, yeah, I'm creating a temporary one. The important part about that is that I actually am declaring it inside the while loop and the for loop, which is typically bad practice. But if I don't do that, here it shouldn't really matter. But no, it should still. It should still matter. You might notice you'll get a bug if you did it outside instead of inside, where all of your tweets or cars or whatever are all instances of the last one you read in, like from first to last, and it might seem strange as to why that is. It has to do with them all being passed by that reference. And you stored stuff in temp, whatever. Yeah, you should do something similar. So make a temporary car, read all the stuff into it, and then push it into the vector. And I do recommend declaring it with the type name on the inside of the, what's it called? On the inside of the loop. If you do it outside, it might overwrite some stuff. So, and then automatically, yeah, without being specified. Yep, by getLine. So it will take whatever character, and it will also check for endline. Which is convenient, because that's usually what we want. Hopefully that answers all the questions. I opened up a million tabs, so hopefully it wasn't too hard to follow. Okay. Any last questions regarding anything C++ related, even anything we talked about last time, or any other questions regarding the example I gave? Okay, don't see any, so I'll leave this open just in case this time. But yeah, so I guess the idea is we're going to start getting into data abstraction, which is just the ability to kind of keep data abstract and make things a little bit more readable. So I have here a struct that I already wrote called person, and it just has a name and an age. So let's say I'm writing a program, and we'll try to keep it simple for now. There's some better examples, but we'll talk about that when we get to inheritance. And let's just say I want to be able to print things that I have in my function or my main. So say I have a struct person and maybe a struct for car, and that is a string, which is the make, and an int, which is the year. So it's similar. So for whatever reason, my program needs both people and cars, and it does something with it. So if we wanted to print these, we can actually kind of make our code look nice using what's called function overloading. So what I'm going to do is I'm just going to write 3 functions right now, and I'm just going to call them print item, because I think print is already reserved. So I'm going to do one called print item person, print item car, and print item int. And I might transfer this over to Visual Studio just to maybe make it easier to see in a moment. But you might be wondering that it's kind of strange, right? I named all of these the same thing, and the current IDE I'm using doesn't show errors, so maybe this is wrong, but I know it should be right. So function overloading allows us to give the same name to a function, and the way it tells which function it needs to actually call is by the what we call parameter signature, which is just a list of parameters that you're giving it. So whether it's going to use this person version or the car version or the integer version depends on what kind of data I actually call the function with. So in my body here, let's just put a person. We'll just call him John. And we'll create a car. Let's call it a Toyota. I don't know. And then int x. That one I'll just set because it's easy. So let's just set some stuff here. So John's name is John. John's age is 45. And then we'll do the same thing with car. We'll say Toyota. The make of that is Toyota. And the Toyota dot, I say year. Yeah. Year is 2004. Okay. So I wrote the function prototypes up here. Let's actually implement them. And I know I'm probably one of the few people teaching this class that might use bad names like this, but you'll notice I put like person, car. I typically use capitals for types and lowercase for variables. But just know this is the type, and that's the actual variable that I can use. That's not normal for C++. I think that naming convention, that's just what I do from other languages. Okay. So if I wanted to print a person, I might print their name and then their age. So this person's name is name Okay, so there's just some quick code. So this prints the person, this prints the car, this prints an integer. Hopefully the code contained within that is pretty straightforward. So now, let's say I wanted to print the stuff that I have in main. So what I can do is I can call print item. So let's say I want to print John. I want to print the car, the Toyota. And I want to print the integer that I had of x. So I can use the same function call and same function name for all of them. And what the compiler would do is it will figure out exactly which one of these makes sense given the actual thing that I called it with. So let's see if the server is actually going to respond. Terminal process failed, couldn't fork. Okay, I think I'm going to move to Visual Studio. I was going to try to use Visual Studio Code because it has support for Sally. But, oh well. Be 2004? Oh, you're right, I did make it an integer. Duh, thank you. Yeah, that wouldn't have compiled. Let's create a new project. Wow, that's taken a while. Let me just open the one from last time. Okay. So, alright, yeah, copied over the code. Oh, whoops. Okay. Yeah, same code. So now if I hit play and compile it, it should print John, then Toyota, then the X. And it opened my console over there. But you see, yep, it called John, printed him out, printed the Toyota out, and printed the integer, even though they all have the same name, right? So just really quick, as killing two birds with one stone, let's just make sure that it's doing the right thing, or just show exactly what the execution is doing here, and then also learn a little bit about Visual Studio. So if you go to debug, you'll see there's this function called toggle breakpoint, which is F9, which is what I usually hit. So if I do that, it'll make a little red circle over here. This will stop your code at that line. So if I was to hit play now and have it compile, you'll notice it actually stopped execution right now, and it also tells you all of the variables that you currently have. So this one will tell me John, it tells me his name and his age, as Toyota has the make and the year, and then tells me the contents of X. That might be a little bit hard to see, it is a bit small. I don't think that actually makes it bigger, oh well. But yeah, nice feature about Visual Studio is that it comes with a debugger that you can do that with. So if I was to go to the next line, which I can hit this little step into button here at the top, you'll see that it goes straight to the person version of the print item because I called it with a person. And then it does the code, leaves. Sometimes you have to hit enter to make it keep going. And then you'll see that once it gets to the end of this function, it's going to jump back up to main because that's where it called it. And then we go to call the next print item, which is with a car, Toyota, and it goes straight to the car version of the function. So function overloading is basically just a way that we can write the same names, just because it's convenient, and then have it call different versions of it when you provide it different arguments. And that'll be more useful when we actually start getting into object-oriented stuff. So does it stop running before running line 35? Yeah. Yeah, it will stop before executing whatever line you put the breakpoint on. Yep. And really great if you're having troubles running your program is to just run it through the debugger on here and then run it on Sally once you're confident that it works. Debugger is great, super necessary. I didn't start using it until I was in like 400 level classes. Life becomes way easier if you start using it now, believe me. It's awful doing some of the programs without it. How do you open it, Sally? So I assume there's some remote feature for Visual Studio. What I would probably do is just open a file transfer protocol client. So for instance, I have FileZilla here. So you'll see, like this is my home directory. This is on my computer. I recommend FileZilla, but WinSCP is okay as well if you have a Windows machine. If you go to Site Manager, this will be a list of all the sites that you've kept. So I have all this stuff from the school. So I have Bobby, but Sally should work as well. Could not be loaded. Yeah, I know. Okay, it's angry that I don't have an Amazon key. If I double-click Bobby, it'll just connect straight to it. Eventually. And this works for Sally as well. Any of the school servers, Sally, Java, Bobby, Cardiac, all those share the same file system. And you'll notice this is the same directory that I had up there. So this is the Sally directory. So I just drag and drop anything. So, if I wanted to copy this, which I know goes there, I could just drag and drop this PHP. And it'll just copy it all over. And it'll ask you if you want to replace files too. So I could say, yeah, overwrite the source as newer, and then just do it. And then you just SSH into Sally, and then you can compile it like normal with wherever you put the file. So just used a file transfer protocol. And then Visual Studio, Visual Studio Code, there's a way to set it up. And then it's located over here on the Remote Explorer button. And then you can just hit plus here to add a new target. So I already put Sally in. And then it just asks you to log in every time. But I encourage you to run it on your own machine first to test it, because I don't think the debugger is like easy to set up on Sally. And debuggers are great. Plus it has like the IntelliSense stuff on Visual Studio, so it's a lot easier to type. But I digress. Any questions on function overloading? That's really as simple as it is. Actually, I guess there's one last thing I should mention. So, yeah, I guess actually I should do two things. What would happen if I tried to run this code now? I guess I should stop it. Oh, what was that? Anybody have any guesses? So we had a print item for a person, a car, and an injury. Exactly, right? Yeah. If I try to run this, I should get a compiler error. Oh. No, it ran. Is C++ allow that? Oh, that's dumb. Hang on. Does it actually let you do that? Is it just going to give me a memory error? You can also set other breakpoints, I guess, as an aside. So I'm going to set a breakpoint here, and if you hit continue, it'll just keep going until it hits it. Does C++ allow that? Yeah. I'm sorry, I don't do a whole lot of C++. I do mostly C#, and C++ is very... It's inconsistent, and it kind of does things that don't make sense sometimes. So it prints the integer. It really... Oh, wow. I was going to do an example of it going the other way. Yeah, so never trust me on anything. I'm totally wrong. Wow. Yeah, I was going to do an example where I turn this into a float, but I guess that doesn't matter anymore. Yeah, so it'll actually just take the integer one. That's strange. Okay, that's fine. I guess that's okay. I wonder though. let me check one last thing. If it lets me do this, I will be astounded. So let me change this so that it takes a float instead. I know it's called integer, but let's just be lazy. Let me call this a double. Does it still compile that? Ah, there we go. Eh? External reference in main. One unresolved. More than one instance overload matches the argument list. Now that also doesn't make sense as an error. Oh, because that's why. Flip. Okay. It should still hopefully give me a compiler error. No, it doesn't. Wow. Is it actually going to call the right one? Okay. That's kind of bad. I'll explain why it does this, but it shouldn't. In other languages, it won't allow this. Like Java, C#, it doesn't work. It will get angry at you. So, I guess what C++ does is, as long as it's a number, it will convert to that number automatically. So if I change this to a float and it's an integer or a double, it will just coerce it for you. So remember, coercion is like converting from one type to another. So in other languages, typically if you have something that's more precise or doesn't really make sense to convert between, it will not actually convert it. It will make you explicitly write it or do an explicit cast. So in like C#, I would have to do this. I'd have to specifically say, turn that into a float so that we call the float version of this. So that's why I was expecting something different. And that just has to come with, or it has to deal with the fact that a double, if you remember, is double the precision of a float. So when I call it with a float version, I'm losing precision, and it shouldn't automatically do that. You should have to explicitly ask for that. But if I went the other way from a float to a double is larger, right? So it's not losing precision. So that one makes sense, but the other way around, the way that I'm calling it right now, doesn't. Okay. Fair enough. Yeah, I guess I'll just leave it at that. So just, I guess, no, C++ will automatically convert it to something that's similar. So in this case, if they're numeric types, like integers, floats, doubles, longs, it'll just do it automatically, I guess. I didn't even know that. Any questions on that? Oh, hopefully that tangent I went off on wasn't too bad. Everybody understand function overloading? Okay. Yep. Okay, fair enough. If you have any questions, just stop me. Alright, so yeah, we have extra time. So let's get into the topic that I had scheduled for next week, which is not really that crazy, which is classes. So maybe now's a good time to talk about header files too while we're talking about this. Let me move the chat somewhere like here. So in CS 135, they only teach you about structs. And the reason they do that is because it's very easy to use a struct. There's no extra setup. We kind of just write it and it works. So today we'll talk a little bit about something that's pretty similar that more people use, I would say, which is called a class. And really there's one difference between a class and a struct. They're basically just the same thing. You access things the same way. They both have the same features. You could do exactly the same thing with them. The only difference between them is how you're allowed to access data. So while we're talking about that, let's also talk about header files. So you probably haven't used header files before because really we haven't had a need to, and you never really need header files. It's more of just a convenience thing, and it is a C++ exclusive thing. Most other languages don't really need you to write something like this because most other language has, the compiler does 2 passes, which means we don't even need like these function prototypes. So related to that reason why we need a header file. So I'm going to add a new item right now. So I'm going to create a new header file. And let's just think of something cool. So I don't know. Let's think of something that's fair. This is something like animal. I almost want to do something more in depth though. Well, let's stick with that for now. So I'm going to create a file called animal.h. So .h is how it tells it's a header file. Add. Okay, so Visual Studio adds this. We don't actually really need it. So what I'm going to do in this header file is I'm going to create something called a class, and I'm going to call it class animal. So declaration works exactly the same way as a struct. So now let me just pretend I'm using this like a struct right now. So an animal might have a name, and I should actually in this file include string so that it knows that there's string there. Maybe you want string.h. No? Oh. Using namespace standard. Right. That should... Really? There we go. Okay. Just normal string. So, let's do an animal class that has a string for a name, integer for an age, and we'll just leave it at that for now. So let's do 2 things. One, so I've written this in a separate file, right? Which is nice because it allows me to organize things. If I end up writing a big project where I'm going to have, 100 classes and structs, then I can put them all in header files. So if I had like a game where I have enemy 1 is written in, and enemy 2 is written, and enemy 3 is written, and I have code for all of these things that do all these separate things, then it's a good idea to put each one in its own header file, and usually its own CPP file as well, and then just compile them all together. So I can separate data just for easier reading by doing something like that. But the problem is, like, how do we know in this function where main is, because main is always the starting point of your program. How do I know that I actually wrote this file? Well, the way we do it is basically the same way we do everything else for importing stuff, which is using an include statement. And then if you want to include a file, you use quotation marks, so you just give it a string. And in this case, the name of my file was animal.h. Okay, you'll see there's no compiler errors. It's okay. So what that means, and it's very important because C++, again, is strange. The compiler only runs through once, which is kind of a unique thing to C++ and C. I guess scripting languages like Python might do it too. Is the order I put these includes is actually very important. So if I had another header file and put it underneath it, it will import animal first, and then, if I put like include test.h, which isn't a real file, it will import animal first, and then it will import test. And it's basically just the equivalent of the compiler taking all of this code and just pasting it right into where the include is. So very important to note that, because the order you do it in might be important if they share names, or if one depends on the other, or something like that. So very important to know that those actually matter with the order in C and C++. But anyways, now that I put that there, it's basically just going to take everything that I have in this file, animal.h, and just copy and paste it into there. So all of this, which is really just a namespace and a class declaration, is just going to get pasted. So now, if I was to make an animal, this program should know that it exists. So really quick, just to keep with the stuff that I've already written, let's just do a void print item for an animal. Okay, and then I gotta... Yeah, okay, that's supposed to happen. I wanted that to happen. But we'll come back to it. Let me just make sure I have the function prototype for it. Okay, so I've created a new function called printItem that works for the animal now, and you'll notice it at least recognizes the fact that I have an animal. So the fact that I put this include here, it means it knows that that exists. It didn't say, undeclared in the scope or anything like that. But you'll notice it throws some other errors at me, and it says, hopefully is inaccessible, right? Member name and member age are inaccessible. So that's really our difference between a class and a struct, is accessibility. So, you might be asking, what does that even mean? Which is a fair question. So, if you're familiar with Java or C#, more object-oriented languages like that, you kind of have to learn a little bit about the public and private and maybe protected keywords just in order to use that language. So that's where this comes into play in C++. So when I use classes and structs, I have these things called modifiers. And what modifiers do is they tell me when I'm allowed to use data. So if I wanted this to work like a struct, what I have to do, and the syntax is a little bit different in C++ from Java and C#, is I need to put the word public and then a colon, and then everything following that will be public. And you'll notice here that now my error is gone. So what a public variable means is that anybody can access it. So if I was to go here and access the name and access the age, then I can access it now. But if I was to try and do that when it was private, which is what it's marked by default previously, it will tell me that I can't because I'm not allowed to access it. So private means that it's only accessible to itself, and public means that everybody's allowed to use it. Does that make sense so far? The difference between those. And so the only difference between a struct and a class is that a struct, everything is marked as public by default, and in a class, everything is marked as private by default. Any questions on that so far? I know I'm probably going to get the question of, like, why would you even want that? Which is totally fair. No, none of this is really necessary. It's just niceties for programming. Okay, so let's do some more stuff with that then. So let's say I actually wanted some private variables. So there's a couple of reasons why you might want a private variable. So if your class is very complex and it has difficult to understand code that does something that you can't just inherently look at and think, wow, that makes sense, then you might want the variables to be private, because somebody else who's using your code, or maybe you at a later time, you don't want that person to mess with the code. You don't want them to overwrite any variables and like accidentally set or overwrite any of the things that you have. So that's generally an idea of when we want to do private. On top of that, maybe the variable that doesn't even need to be used by the person. It's something that only needs to be used in the context of your class and then never used outside of it. So you don't even give people the option to use it because using it doesn't really do anything. It's just maybe for one function or something. So I'm going to change these back to private really quick. And so now my program won't compile anymore because this doesn't work. So let's talk about how we can get around that and how it might be actually nice to code this thing. So I'm going to cut this and I'm going to move it. So one of the great things about structs and classes that we haven't gotten into yet is that they don't just take members, like variable members. So these are my variable members. They're primitive types, so a string and an integer. I can also put in functions. So now I've copy and pasted this print item, so I can actually get rid of the function prototype here. And now belongs to the animal itself, which means I can use that function with any animal that I have. So you'll notice maybe a couple of things, which is, well, maybe just one thing, I guess, which is that I don't get that error again with the inaccessibility on this. So when I have a private variable, it can only be used in functions that belong to the animal itself, or the class itself. So this animal class, because these are private, it's allowed to use any of them. But if I try to use them outside of the class itself, so let's say I make an animal called a cat. If I try to do cat.name equals cat here, you'll notice it doesn't allow me. So again, private variables, which is what this is marked by default, and maybe I'll just put this here to make it clear. Those can only be used in the context of the class. Anywhere else you try to use them, any other class, any other function, it's going to tell you that it's inaccessible. Any questions on that part? That's really just the basics to private and public. In the header, do you also need iStream to see out? Yes, you're right. Thank you. Yeah, make sure the header should basically be self-contained. Everything that you need, you'll need to include inside of it. Okay. So then let's just go over maybe 2 more things before the end of class. So one problem you might notice is that if I went back to here, I'm not allowed to do this anymore, right? Not allowed to set name, not allowed to set the age. So if I was to just try to print the animal, I should get an error. Let me do 2 things. One, I guess one nice thing is I actually don't need this animal anymore in the parameter. When I call a function, it knows that any of these variables belong to this specific instance. So when I call this, it will know that there's a string for this one called that. So really quick, the way I would call that is just the way that we normally access variables, which is with a dot operator. So I could say dot print. Oh, one thing. Right now, this function is actually private. So I can make just this public. Oops. Yeah. So now this function is public. These members are private. So main is not allowed to do anything with the name or the age, but it is allowed to call the print function. And notice that should compile. It should give me an error. That's because I haven't done something yet. In fact, it probably just prints random garbage. Yeah, animal's name is blank and age is negative 85 trillion or something like that. So it worked correctly, but these definitely aren't right? Okay, so we'll need to talk about fixing that. So that's where I was going, was I can't set the name and I can't set the age in main anymore, right? So that's a bit of a problem. So let's say we actually want to do that. So there's another type of function exclusive to structs and classes, and it's called a constructor. And so what a constructor does, and you've been using them this whole time, you just don't know it because C++, again, it does things a little bit differently than every other language. It uses a constructor without telling you that it used the constructor. A constructor is used to initialize a class whenever you create it. So, for instance, on this one right here, it's using one that I didn't even write. The compiler just generates one for you that does nothing. So what I'm going to do is whenever you make a constructor, you just call it whatever the name of your class or struct is, and then you give it a parameter list. So I'm going to do one with none. And then, like we were talking about earlier, we have this function overloading now, right? String name in age. Okay, so now I have a constructor that takes no parameters and a constructor that I can give the name and the age. And we'll go over how to call those in a second. But let's just say when we create an animal, let's just give it a default name of animal. And we'll give this one a default age of 12. Okay. So I don't know why that's, yeah, okay, sweet. So you'll notice now, if I have a parameterless one, like this, what's going to happen is when I create the variable right here, animal cat, it's going to go and call this. So a constructor is actually technically a function. It's just a special kind of function. So it's going to go there and it's going to automatically call this and use it to initialize all of our values. So if I was to go and try to print the cat now, you'll notice it should say animal and 12. Right? So the animal's name is animal and age is 12. So when you don't specify anything and just create a variable, it will always call this default constructor, which has no parameters. But you might not always want that because, like we said, we can't really overwrite things, at least with the way we have it set up right now, in the main function. So maybe we want a different way to set this up. So another way we could do this is we could take in a name and an age to start with and then use those to initialize it. So maybe I'm going to call this start name and start age. The way I had it set up is totally fine right now, but maybe we'll talk about it next time. So I might want to set name equal to the start name I'm given and age equal to the start age I'm given. Okay. So again, weird C++ syntax allows me to do this in a couple different ways. So what I could actually do here is I could call this, and it should let me do it this way, and I could say I want the name of this to be cat and I want its age to be 4. So I can call the variable like it's a function because this constructor name is basically just the name of the type anyways. And this will go and fill those values in. So let's actually just watch what happens when we run this if I throw a breakpoint right here. So if I run the program, you'll notice that when it goes to create this animal cat, it will, if I go to the next line, go straight to this constructor that used a string and an integer because I gave it a string and an integer. And it will use that to initialize the name and the age. And if I continue, you'll see it got just that. So we have an animal named cat and an animal with an age 4. And so the great part about that, with the way I have it set up, is that you can force the person using it to give you these values to start with to initialize your data. But now, because we can't do any assignment in the main, right? I'm not allowed to say cat.name equals cat2 or something like that because I have a accessibility issue because the variable is private. I'm not allowing the user to overwrite the value at all. They're only allowed to set it once, and then they never touch it again. And that's good because maybe we just don't want them to overwrite it, and we want them to decide on it right when they create it, and then not be able to change it later. Does that make sense so far? I know I'm throwing a whole lot of new programming stuff. So if you have any questions, just stop me. when we start implementing this into assignments, I think the next one, I can check. We have a general outline of all the assignments. Makefile syllabus. I guess I don't have it. I saw it at some point, but I guess I didn't get sent it. Probably in the next assignment. You'll for sure need to have classes, public, private, and constructors. Yeah, it's being recorded. I'll upload it on YouTube later. Any other questions on this? I'm going to do a little bit more with regards to constructors here in a second. I'll try not to do too much new. You know, I don't want to overwhelm you guys too much with like a million new programming things all at once. Okay, I don't see any questions, so let's just talk a little bit about instantiation, I guess, with these. So, if we go back to that constructor that I wrote that takes a string and an integer, I can conveniently make a bunch of different animals that all have different fields just by using that constructor. Okay. Yeah, that's the same comment. So I can go and make more constructors that will just call the same way because they know they have a string and an integer, and they'll initialize whatever these variables are to that. Let me, just for the sake of the example, let me name this something different. Let's just say the dog's name is Fido. So down here I'm going to print them. Again, I can just call it with the dot operator because the print item is located within the class now. Okay, so if I call this, you'll notice it will print the cat, dog, and bird, and all with the different values that I initialized. So animal's name is cat, and age is 4. Animal's name is Fido, and age is 10. And animal's name is bird, and age is 7. So I can create a bunch of different instances of this same class. So this goes back to, I guess, what I was talking about last time. So a class is kind of like a blueprint of stuff that a instance of that class should have. So the cat, dog, and bird, those are all instances of my class. They're all like physical, tangible objects that I've created and can use in the context of my program. But the class itself is just a blueprint that describes those things. So all this stuff in here, whenever I call any of these, you'll notice I just put name and age, right? But it always knew to use the name and age that belong to that specific instance. So like the dog, that used the name Fido it got, and the bird, it got the name bird it got. So all of these have their own individual attributes. Instances are kind of like individuals. They're unique. They have their own things that when they're changed, it reflects itself only in them, whereas a class just tells you how those things are actually set up. And Structs is the same thing. Okay. So I think that about covers that part. We still have about 10 minutes. So let's see. Because it's class, you and do cat. I'm not sure I understand. So you mean like because it's the class of animal, I do like animal, cat, or I guess the cat is an example of an animal class instance. Does that answer your question? Hopefully. So like this cat, dog, and bird, these are all instances of an animal. So they have all of their own individual names and ages that are described by what an animal class is. And so this right here, when I do the left parenthesis, right parenthesis, what is constructor doing? So a constructor is a special type of function that only gets invoked when you create a class. So again, let me delete all this stuff here. So if I was to execute this program from the top, you'll notice person and car, because I didn't give them any constructors, it just skips over them, it does nothing. But when it gets to this animal cat line, you'll see that the program actually jumps straight here to the constructors section that I have. So a constructor you use to initialize any data that you want to be initialized for that class or struct. So if you know you need data to be set when first starting out with something, then you want to use a constructor. And if you don't put any arguments, what happens is it will automatically call the default constructor, whether you have it written or not. If you don't have it written, it just generates one that does nothing. But if I do have one written, what it will do is, like we just saw there, when it gets to this line where it says animal cat, it will say, well, I'm making a new instance of an animal called cat. So I'm going to have to go and look at a constructor and do all this stuff in the constructor when I create it. So a constructor gets called whenever you create an instance of something, so whenever you declare it. Although there is another example. Does that make sense? Okay. So when I do it this way versus that way, yeah, so it's exactly like a function call. So these really are just functions, but like a special type of function. So what it does is similar to our function overloading up here, right, where we said, oh, print item, print item, print item, but they all had different types. What the compiler does, is it looks for, if I did this one versus this one will see, well, I didn't provide anything to it, so I need to look for a constructor that takes no arguments, which is the default one, which is that one. Versus if I call this one, where I put a string and integer after it, and you'll notice it does look like a method call, or a function call. Oops. I have two arguments. The first argument is a string, and the second argument is an integer. So what the compiler does is it says, well, let me go and look and see if any of the constructors take a string and an integer. And so it'll go through these and it will say, well, this one doesn't. It takes nothing. So I shouldn't use that one. But this one does take a string and an integer. So that's the correct one to use. So it is actually an example of function overloading as well, where we have all of these constructors which have the same name, but the way it determines which one I actually want is by the argument types or the parameter signature that I'm actually calling it with. Does that make sense? It is just a function call, so that's why we use the parentheses, and it's a special type of function call that's only called when you create something. And then it never gets called ever again. That's the only time. And there is different ways we can create things other than just writing data type and then the name. So there are other places where we can get the constructor to create, but it's when we create a new instance of it anyways. So we would be overwriting the old one. Any other questions on those constructors? I think there's only one other thing I wanted to talk about. I'm trying to remember what it was. Oh, yeah, I know. Actually, maybe I'll wait until like a week or two to talk about that. For now, it's not very standard in other languages, especially if you're used to Java or C#. But for now, let's just do all of our constructors whenever we are declaring the class. So always put it like I have here, where it's after the name. There's a different way to do it, but it returns a different kind of data type that we haven't really gone over yet, and it'll take me a while to explain, potentially. But if you're used to Java and C#, then you are probably familiar with the new keyword, and it works a little bit differently in C++ than it does in those languages. So That's why I'm not using that. If you've seen those languages before and are asking, like, why am I writing it this way? That's why. Okay. Don't see any other questions. I'll try to think of something else that's not too long to talk about. I don't want to get into anything too ridiculously new. So the only thing I think I'll mention now is just... Oh, that requires pointers too. I'll just talk a little bit more about modifiers. So you'll notice, like earlier, I had this as name, but the problem with that is that it was like the same variable name as this one. So for the time being, even though it's not common in practice, try to, unless you know about the this keyword, in that case, do whatever. Try to give different variable names here in your constructors than the actual variable members that you have up here. Okay, so the only other thing I'll maybe talk about with regards to this... No, but that would also require inheritance. Yeah, I'm not really sure what to talk about. That only takes 5 minutes. I guess, we'll just say that's a good stopping point. Any questions on anything in general? I guess we'll just take this time to talk about whatever. Yeah. What was your question on assignment 1? Right. Oh. You're right. I think he does have it that way, huh? And they're probably right next to each other. Very good point. Let me open that up. How do we separate that? Yeah. So what I believe you're asking, correct me if I'm wrong, is we have these strange cases where those aren't, like the make and the model aren't actually separated by a semicolon like everything else. So I have like Chevrolet, Chevelle, Malibu. So this is the make, this is the model, right? Yeah, fair point. So in order to do that, we can kind of just assume, and this is really the only way I would think we're going to be able to do it, is to assume that the make is always going to be one word. So use the extraction operator, the right arrow, to read in the make first, and then use getLine to read whatever's after it. Because if you use the extraction operator, it will stop whenever it sees a space. First word is always, yeah, right, I would assume so. So you use the extraction operator to read that in, and then afterwards use getLine for everything else, and then when you get back to the start of the while loop, then go back and use the extraction operator again. It's totally fine to mix and match, because if we do it that way, it will always stop on a space if you just read it into a string. Yeah, exactly. That's the right code. Yep. And then getLine like 4 or 5 times. 1, 2, 3, 4, 5, 6, 7, 8. Yeah. And call getLine 8 times and convert the data. Any other questions on just anything in general? Can we change the cars.csv to a text file? Yeah, if you really want to. I mean, there's no difference if you do it either way, honestly. Just know I'm probably going to test it using the .csv. So I guess I'd prefer you use that, but if you want to make it a text file for testing, yeah, there's not really any differences. Okay, so I guess I'll stick around for questions if anybody has them. Feel free to leave. I guess if you don't have any questions. The only last thing I wanted to say was office hours and lectures I'm doing on WebEx now. I'm going to set up a schedule, hopefully later today when I have time, that will send you an email whenever those are happening. So office hours will be Tuesday, Thursday, 12 to 3 still, and then I guess I'll just wait in a WebEx call. So if you join, just shout at me or something, because I'll probably be doing something else, if it's kind of uneventful. And maybe we'll be forced to do like almost a discussion section with those, or just mute people or do something for your email. It's kind of hard to do private stuff when anybody can join. So oh well. But yeah, I guess if you want to go, you are free to go and have a good day. But if you have questions, I'll stick around for a few more minutes. Yeah, since the first line has the information such as a car, do you... Yeah, read it in and throw it out. So read in the first line and then just don't do anything with it. That's just something that's part of the way CSVs work, and it's not too pertinent to what we're doing in C++, although we could structure it, but it'd be kind of hard. It's more useful for other languages that have built-in stuff that deals with that, like Python. Are we doing error checking? I'm not going to mark you off if you don't do error checking, although it would certainly be nice practice to do error checking. I would at least make sure that the argc is 2, even though it's not error checking in the file. Error checking in the CSV, I'll just say it's fine. You don't have to do it right now. There's an easy way to do it, but we haven't gotten to how to do that yet. Is it possible to use end of file, while loop, and also keep track of the lines read, or should we use a for loop? You should use a while loop with end of file. I guess the nice thing about using this vector that we're using is that you can keep track of all the things if you just read them in and then push it into the vector. If you want to keep a line count as well, you actually don't really need that because the vector will already do that for you. But if you're reading something else, you could always just create a variable and then increment it every time. So basically just use a while loop, create a car struct inside the while loop at the top that gets created every single time you do a new loop, and then read all the stuff to that car struct and then push it into the vector. That's generally what your reading should look like. Alright, I guess if there are no more questions, I will see you guys next week.